You see my age, I'm not a PhD student any longer.
But more time.
Yeah, okay. But you also, just to comment also that I made my PhD in 1988 in the area of integrating wind power in power systems. So I worked a little with these kind of issues we are going to discuss here. Just a little about how it looks in the world. If you see on the top here, I think you can put. There, yes. That is how much energy we are consuming currently in the world, and that is 144,000 terawatt hours a year. This is divided, what you see here is that the fossil fuels, the blue, the gray, and the red here is very dominating. If you see on the electricity side, it's around, this is 144,000, this is 21,000 terawatt hours. That is around what we are consuming in the world. Here we also have coal, oil, and gas. So we have here also a really significant amount of fossil fuels. What is interesting, because some people think that, okay, 21,000 here compared to 144,000, that's not so much. But if you go and see how much, because here we are talking about thermal energy. Here we are talking about electricity. This is not the same. If you want to see how much thermal energy this corresponds to, then it's 55,000 terawatt hours of heat electricity. That is how much you use to get all this electricity. And that means in reality that around slightly less than 40% of all the energy in the world is used as electricity. This is a share which is increasing all the time, because electricity is an important issue. One thing, since I'm coming from power sector, this means, of course, that it's an interesting area. But on the other hand, it's also a challenging issue, since you see that you have a huge amount of fossil fuels, and that means that if the electricity sector becomes more important, then also the fossil fuels, the sustainability is important in this area. So that is the basics of, let's say, the challenges for the electricity sector nowadays. Just to say a little more details about electricity, there are two things you want to have when you have an electric system. One is that you want the voltage. It should be 230 volts when you connect, otherwise it doesn't work. And the other thing is that when you push the button, you want the electricity to come. That is the big challenges, because exactly when you push the button, then it must come from, the electricity must be produced exactly at that millisecond, otherwise it doesn't work. This is one of the fundamental challenges in the power system. And then you should know that the whole grid from northern Sweden through the whole continental Europe down to northern Africa and to the Ural Mountains is a totally one big system which is interconnected. And even whatever is happening with when you push the buttons everywhere, you get an outage in a line, all this system is one big system working together. And that is one of the really big challenges here, how to make this work. And then you have a lot of smartness here, which has the possibility to improve the function of this system. So I will talk a little about what this smart grids is and look also on what are the challenges in the smart grid research. I start with the smart person. When I went to school, a smart person was the one that had 5.0. That means the highest grade in everything. What I normally say today is that smartness is not only to know something, you must do something also. What with your smartness? So if you have your smartness here, what you do when you are smart is that you take the information, you see things, and you know things, you process in your brain, you have experience here, and then finally you do things. The important thing of the smartness is not what you do. The smartness is the consequence of what you do. Not only if you dig, I mean, why should you dig? Is it smart to dig? The question is if you want a hole. The hole is probably not smart either. It's what you do with this hole later. You plant a crop or whatever. So it's the consequences of what you do that is important. And this is the way you get more and more experience in your life. You see the feedback. You do things, and then you see oh, sorry, that was not so smart. And then hopefully you remember it and you don't do it again. And then you try to teach your children to not do the things, but they have to experience these kind of things very often.
or PhD students. That's right. That's your comment. That's why we really need a supervisor. Okay, that tell good things. Okay, the power system is the same. And here you have the challenges that what is happening today is that you can get a huge amount of information today because you have the internet and so on. Internet, and you have a ICT system, you have phase measurement units in the power system and so on. So you can measure a huge amount of things. You can measure the wind, you can measure the power transmission. Today, everyone in Sweden have a smart meter at home so that you in some way can get the information. Is it electricity out there or isn't it? I mean, 5 years ago, the only way sometimes for power companies to know that there's an outage is that someone is phoning them and saying that I don't have electricity, if their telephone work. Today, you can have monitoring. Some companies have that of everything, so directly when there's an outage, you know exactly which persons that don't have electricity. So that is, of course, a smarter thing. What you can do then is that you can perform actions, and today you can make much more actions than you could earlier. That is the idea now, that you can send out information to households to change things. You can control a lot of different things, power systems, you can control the generators and so on, in a much smarter way, and that is the experience. What you can do today is that the smart thing is not that you send a controller to a transformer to change something. That is not a smart thing. The smart thing is the consequence of what is happening if you send this signal. What you can do today is that you can build up very good and accurate models so you can simulate the consequences. And then, of course, it's much easier to take smart decisions. So the information, how much time do you have? I can talk for hours, no problem.
I will stop you, okay?
Okay, you stop me. Okay, then I consequence. So the information is, of course, important, so you know what is happening out there. The controllability is important, so you know what you can control. I mean, it's no meaning of being smart if you not can do anything. The more things you can do, the more possibilities you have to choose, and the smarter you can be. The consequence analysis is essential here. So you really know, if I do this kind of thing, if I, for example, I send out a signal to change the temperature in all freezers in Sweden, you can do that and then they reduce their consumption. Okay, is that important? Then you have to look on the consequence analysis. Otherwise, you shouldn't do it if it's not a smart consequence. The action is not smart in itself. It's the consequence of the smart. That is the smart grid nowadays. It's how you do these kind of things. Just some small comments to this with smart grids. Some people say that smart grids are needed. Otherwise, you cannot have more wind power or more solar power. I don't agree on that is so-called needed. If we stop the IT development, does that mean that we cannot have more wind or solar power? Of course, that's wrong. It's just that smart grid you should do because it's a smart solution to have all these signals. Otherwise, you shouldn't do it. Then there's an idea, some people say that, oh, smart grids is very good. You can have reduced losses in the system. I say the opposite. Normally not. The whole idea of having a smart grid is that you can use your system closer to the physical limits. Instead of having a huge amount of margins with a lot of more information, you can use your lines much more. That means in reality more current, less copper, because if you are not smart, you have to build more lines. More lines means more copper, lower losses. So probably very often, smart grid can make higher utilization of existing resources. There you earn the money. How much will smart grid cost? It shouldn't cost you anything. You shouldn't do it. It's not smart to do things if it becomes more expensive. The driving forces for smart grids is something like this. If you are some economist here, you recognize the type of curves. If you have more intelligence in the system, there I talk about sending all these IT signals, have a huge amount of computers. Of course, if you start to do something, the value is very, very high. But if you start to measure every consumption everywhere in the system on a millisecond base, I can say that, okay, it will cost you a loss. The value is very small. So it's the more you put in, the lower the value. And at the same time, the more you have, you start with the cheap solutions, and then it will become more and more and more expensive. What is happening? And that means that here you have, this is traditional economic analysis. Here at this level, you have that the cost is equal to value. Here in this case, the value is very small, the cost is very high. You shouldn't do this kind of thing. What is happening today is that two things. You have an increasing value of having all these kind of signals sending around. And that is, for example, that you get more wind power. It's changing more. You have more solar power. You have the installed capacity in Germany currently in solar power is double as high as nearly double as high as the installed capacity in nuclear power in Sweden. And that means that is not from the energy point of view, that's something totally different. But if you see the changes, can be significant. Just one interesting thing. It can be in Germany that the power prices are cheaper in the day than in the night. There is some kind of discussion of, for example, if you have an electric car, load it, that's smart. Load it in the night when the power is cheaper. No. Not if you have solar power. It can be cheaper in the day because you have so much sun. And that means that it's an increasing value. So you have a higher and higher value of all these kind of smart solutions. And on the other hand, and not on the other hand, and at the same time you have decreased cost. All these kind of ICT solutions today are much cheaper than earlier. And that means that since the value will be higher and the cost will decrease, you will see more of this in the future. Just one example where you have seen the challenges. And these are about the 2020 goals that we should, for example, have much more renewables. This is example from Spain, Portugal, and Ireland. In Spain, you have today, in 2010, 16% of the electric energy came from wind power. Portugal 17% and Ireland 13%. If we should in Sweden have 17%, the same amount as they already today have in Portugal, we should have more than 20 terawatt hours of wind power. Today we have 5. So these are the situations they have already today. Wind power, the maximum share in May this year, that is when you have low load in the summer night, in May night, you had 80% of all the power in Portugal was produced in wind power. Then of course you need kind of smart solutions of how to arrange this kind of thing. Because this is very relevant for what is smart, what should you do for kind of smartness in your houses? Should you store energy? Should you have your own solar power? Just to say something about how this will work, and that is very much related to the price on the power. What you should do in your house, for example, you should consume when it's a high price, and you should consume when it's a low price, or you should store energy from a low price to a high price situation. How the power system works like this, that here, you have this is the consumption during a week, and in this situation you have a very high consumption. In a high consumption situation, you should produce a lot. How do you force the producers to produce a lot? High prices. You have to have high prices if you want a high production, otherwise they will not produce. And then you take here in the night, for example, in the night between Saturday and Sunday, you don't want them to produce so much. How do you force them to disconnect their power plants? You have a low price. And this has nothing to do with if you have certificates for wind power, feed-in tariffs, or anything. This is what the other ones should do. So that means that if you have a varying consumption like this, then you must have a varying price. High price, you should force them to produce a lot. It must be a high price. And that is the interesting thing, because if you want a flexible house or that you produce something more, you load your car, whatever, it has to do with the price difference. Then the question is, what happens if you have a huge amount of wind power? You will have another structure. You will have, if you have, for example, this here I just put in this as a synthetic example, but you have a huge amount of wind power. Then you can, here you, for example, have a huge amount of wind. And that means that you don't nearly need to produce anything else than wind. Okay, what happens to the price? It has to be low, extremely low. Otherwise, you don't disconnect all the other power plants. That's the only way to get they not producing anything. And then you have a situation here where you have no wind. Okay, so then in this situation, you must have a high price. Otherwise, the other one will not produce. You have to have a higher price because otherwise they will not produce. That means that this shows how the price is changing. Remember, with wind power, then you have to understand, if you want to understand if your flexible solution, your car loading, changing or whatever is smart or not, or you are disconnecting your fridges, then you have to understand how the wind is moving around. And the wind is not changing from 1 second to the next second in whole Sweden. You have ramps of, let's say, it's very windy for 3-4 days. Then it's very low prices for 3 and 4 days. Then it's no wind for 3-4 days or 2 days. Then it's very high prices for 2 and 4 days. This is really essential when you start to talk about your flexible solution, storage energy, using batteries for balancing and all this kind of thing. You must remember we are talking about huge amount of energies moving over days. It's not from 1 hour to the next. Okay, so we need more kind of flexibility in the system so you can manage all these kind of changes when you have huge amount of wind power or solar power. Remember, we are currently in Europe, in at least on some levels, we are discussing, for example, 50% of the energy in Europe from renewable energy. Huge lines from Northern Africa combined with solar power in Southern Europe, hydropower in the Nordic countries, Switzerland and so on, and a huge amount of wind power in UK. You will have a huge amount of flows all over Europe if this is happening, and then you need some kind of smart solutions, big grids, this kind of thing. Then you know that there must be how to make these kind of changes in the system. You have a different kind of solutions. You can have more trading with your neighbors. If you have a huge amount of grid all over Europe, sometimes called copper plate Europe, more or less that you have any lines. That means in reality that you can send power from Spain to Sweden or in the opposite direction how fast you want. Then you will never get any local price changes. Because if it's not windy in Sweden, okay, it's windy in Spain, and then we just import, and then we'll not get very high price changes in Sweden. And that means that all the smart solutions are not interesting any longer. There's a discussion in Denmark currently, for example, that in Western Denmark you sometimes have negative electricity prices. You have had it in South Australia also. Negative prices means that you are paid to consume. Okay, very interesting. And then perhaps you start in Western Denmark to start to consume, and then you suddenly come with a big transmission line to Denmark. All the price incentives to do this kind of thing is uninteresting. And that means that you in reality have a competition between different kind of, let's say, demand-side management, that you change your consumption depending on the price, and more transmission. You start with these kind of things, and then you come with a new transmission line to the area, and you have destroyed the market for this kind of thing. Then you can have flexible power plants, and that is what is happening very much now. You have flexible nuclear power. I mean, today in Sweden, if you talk to a power producer, no. With nuclear, I run it all the time. I never change it. I don't. Why they say that is because they don't want to have so low prices, so they have to decrease, because then they don't earn money. So, of course, what is happening now, you have it already in France, in southern Germany. You have flexible nuclear power plants that is changing their production depending on the demand. So, challenges? 2 minutes more?
Yes.
Okay. So challenges with smart grids. It's a huge amount of challenges here. We are talking about, in the world, 40% of the electricity today. If we want, because I saw also, the big solutions to get renewable energy today is solar power. Last year, it decreased with 50% the price in 1 year. I heard that in southern Italy currently, it's nearly on the parity what the consumers pay for electricity and what is the price for solar power. It has decreased significantly, this price. If it's continuing the same way, it will be a really interesting development you will see in solar power. The big solutions to get, let's say, more renewable energy is wind power and solar power. There you really have the large potential. Then you will get a really big need to have flexible systems. Challenges is, of course, method to estimate the values of different kind of flexibility. These are huge challenges. Should we have a lot of smart solutions in Sweden, and then you come with an overlaying transmission grid, and you have destroyed the whole price incentives to do this kind of thing? What is the smart and the cheapest solution for that? It's really huge challenges. Efficient ICT solutions. For example, if you want a person to react at home, they should do something with decreasing their temperature or something. Should you send a signal to the meter, or should you send an SMS? If you want a person to react, you shouldn't send a signal to the meter. You should send a signal to the iPhone or whatever. And that has to do with what kind of actions you expect from these persons. So efficiency ICT solutions is you also have to think about the persons. Do you want to control an equipment, or do you want to send an information to a person so they voluntarily can take a decision? The question is also how they react, so you have to know something about that. Efficient demand-side management solutions. I will show you one very small thing in 2 minutes, half a minute. Efficient grid control technologies. There is a huge amount, and then fortunately we have in Sweden the company ABB, which are very world leading in some of these technologies. So there's a large possibility to do this kind of thing. Electric vehicle integration is a large issue today. The question, you have this fast charging and so on, which is very interesting, and then that is a very big possibility to charge when there are low prices, if it's possible, and if people want to do it. This is my house in Ekerö. Just one small issue. I use wooden pellets. Today, because I have problems in that one, everyone that work with burning knows that it doesn't work so easy always. And what is happening is that then the temperature go down, and then I have reserve electric heating. So this is my thermostat here. That says that when it's lower than 40 degrees, I put on the electricity. I could have another one here instead. When the power price is lower than a certain level, so the power price is lower than the cost of my pellets, I put on the electricity instead. Very simple thing. This is an extremely smart solution, because that means that when the power price is low, what you, for example, could have in Western Denmark, then, of course, you could just use the electricity to heat. But then you need, of course, hourly metering. I have to pay per hour. Otherwise, I don't save any money if I don't do that. So you have to transfer the price out to but in reality, I don't need a very smart meter. I just know to send a signal to my burner here. So this is just one example of a smart, so-called smart solution. And then, of course, I can go and change the thermostat. No, I don't want to have electricity, or I always want to have electricity, so I just arrange the price instead. This is just one smart, but this is really huge amount of energy that you could do like this. And that means that if everyone with thermal heating at home today had this, you can have much, much, much more wind power, because that means that when you have so-called surplus, everyone wants to start to use this one instead. We are trying to estimate the potential of this currently. Okay, I think I stop there.
Thank you very much,
Lennart. Thank you.